In today's video, we're going to look at using an open source tool called Lightstream, which works with SQL Lite to rapidly include cost-effective automated disaster recovery functionality to new ServiceStack applications using our Lightstream mix templates. SQL Lite is an extremely convenient way to use SQL in prototypes and smaller applications. We use it regularly for demos because it runs in the same process as your application and can work both in memory as well as persist to disk. You don't have to worry about running an additional server, and with tools like ORM Lite, we can perform a lot of the same tasks as other SQL solutions without that extra hassle of another server. For applications that don't need to scale beyond a single host, SQLite can be very appealing because it's embedded in your application, and just this fact can simplify your infrastructure to just a single host. However, just because your application is small in scale doesn't mean the data it stores is any less important than larger applications using separate dedicated SQL systems like MS SQL, MySQL, or Postgres. Your single instance application using SQLite can always persist data to disk to prevent data loss between restarts, but what happens when your host has a hardware failure? Now you need to think about what is commonly referred to as disaster recovery. You can set up automated backups yourself by using tools like rsync to copy the SQLite file to a remote storage server, but things start to get complex as you try to reduce the time window of possible data loss, file locks, automated recovery, and many other related issues when it comes to disaster recovery. This is where Lightstream steps in with an elegant solution in keeping with the simplicity of why you might be using SQLite in the first place. So what exactly is Lightstream? Well, to quote the Lightstream website, Lightstream is a streaming replication tool for SQLite databases. It runs as a separate background process and continuously copies write-ahead log pages from disk to one or more replicas. In this video, to illustrate exactly what Lightstream does and how you might use it, we're going to walk through how easy it is to start using Lightstream with SQLite and how you can use it with our mix templates to quickly add this disaster recovery functionality when you start your next ServiceStack project. Out of the box, Lightstream works with a lot of different storage solutions, including AWS S3, Azure Blob Storage, and SFTP. But for this video, we're just going to stick to AWS S3 as our storage target. But we will also need a few things installed locally for testing. This includes the .NET 6 SDK, the Windows subsystem for Linux running a Debian distribution, or alternatively Docker Desktop for Windows, and the ServiceStack.NET X tool. If you don't have the ServiceStack.NET X tool installed, you can install it using the command .NET tool install-gx. Although some versions of Lightstream run on Windows, at the time of recording, Windows isn't a well-supported platform. For this reason, we will be using the Windows Subsystem for Linux, or WSL, and Docker to demonstrate how to run Lightstream with your application, both locally and in a deployed Docker environment using Docker Compose. Links in the description for guides on setting up WSL and Docker Desktop if you don't have it already installed on your system. Once these dependencies are installed, let's look at creating a new ServiceStack project using the ServiceStack website. We will first start with a blank web template, add SQLite persistence, and show Lightstream working locally on your own machine to demonstrate what the main Lightstream commands are doing. Then we will use one of the JavaScript-based Jamstack templates and mix in Lightstream support to show the bookings example application working with auto recovery on deployment in a Docker environment utilizing Lightstream. Navigating to ServiceStack.net and clicking at the top right on the Get Started button, you will be greeted with a series of project templates that can be further customized if you know what technologies you will be using. We'll start from a blank solution by scrolling down, providing a name, and clicking on the web template. It will download your new solution in a zip file, which you can extract to your local working directory of your choice. Once extracted, you can use your favorite .NET IDE to open the solution, where you will see 4 standard projects. To learn more about this standard setup, check out our fundamentals video on the app host or on the ServiceStack docs. But for this video, we'll be mainly working with configuring our SQLite connection in the app host project, and adding rows to the database in the Service Interface project. Since Lightstream is a tool for SQLite that persists data to various storage solutions, we've made multiple versions of a mix template where you can mix everything you need to set up Lightstream with specific storage providers such as AWS S3, Azure Blob Storage, and SFTP, which includes automated deployment using GitHub Actions. Each mix template contains 3 main files and installs the ormlite.SQLite dependency needed to integrate with SQLite. Those 3 files are the optional configure.db.cs file, a Docker Compose template, and a GitHub Actions workflow. The optional configure.db.cs file in the AppHost project configures ORMLite with SQLite and a file name connection string. The Docker Compose template file sets up to run your new application in a Docker host with Lightstream as a sidecar container pointing to your database file, and the GitHub Actions workflow that uses specific secrets to automate the deployment of your applications via SSH to any Linux host that supports Docker Compose and is already running the Nginx proxy containers. So as you can see, there are quite a few moving parts here to create an easy way to deploy your application using GitHub Actions. So first, we're going to get our project set up to simply insert data into a new table and get Lightstream running locally before we look at everything working in a deployed environment. We will start with AWS S3 as our target for the Lightstream replica of our database, so this means we'll use a template called Lightstream-AWS. We can mix in these files from this template by running the command xmix space lightstream-aws from the root folder of our project. Looking in our AppHost project and the new configure.db.cs file, we can see the ORMLite connection factory using SQLite is set up as an IOC dependency. Here it's using the connection string of app_data / the name of your project.SQLite. This is our connection string, and it will create our SQLite file relative to the AppHost project if it doesn't already exist. Configure.db.cs also contains an example table class called myTable, and we can use this example and create the table if it doesn't already exist on the startup of our application. So as a simple example, we're going to take this table and insert a new row with a name every time our example hello service is called. To do this, we'll need to move the myTable class to the Service Interface project, as well as installing ServiceStack.orm Lite package into the same project. Now we can alter the existing hello service to insert our new rows and run our application to test our service. When our application starts up, we're greeted with the default landing page with the hello service wired up to this text box, which makes a call every change as you type. Typing into this box a few times and we should have a few rows in our database. We can validate this by opening up our SQLite file with Writer and make a query to show all the rows in our new table. And here we can see each of our calls are being saved to the database. Stopping our application for now, let's use Lightstream locally from the WSL to replicate our database to S3. We will first need to install Lightstream locally. The Lightstream website has an install guide for both Mac OS and Debian-based Linux hosts. I'm running Ubuntu 20.04 via WSL, so I install the Linux version using wget to download the Debian package and installing it using dpackage. We won't need it running as a service since we are just testing it locally for now. Once we have Lightstream installed, we will then need to make sure that we have programmatic access to AWS and the S3 bucket we want to use for our storage. You'll need the AWS Access Key ID and the AWS Secret Access Key environment variables populated to use the Lightstream CLI directly. If you don't have these details set up, have a look at the Lightstream guide for how to set up an IAM user with the required AWS access to use Lightstream. With these credentials configured as our environment variables, we can now use the Lightstream CLI and use the replicate option, pointing to our local database file and remote S3 bucket path. Using a WSL terminal and navigating to our app data folder in the app host where our SQLite database file is, let's run the following command. Lightstream replicate, then the path to your local SQLite file, space the S3 path including your bucket name, and ending with the name of your database file. Running this command for the first time, you should see the initialized DB with the local path and replicating to with the details of your remote storage. A snapshot should be written, which is the current state of your SQLite database file written directly to S3. This process continues to listen for new changes to your database. So while Lightstream is running, let's start our application using .NET Run from another WSL terminal. Running the project from Rider can cause some file security issues which can prevent Lightstream from syncing changes. So while we are testing locally, we will just use .NET Run from a WS terminal to avoid that problem. As we make requests into our default landing page, rows are being created and Lightstream by default will sync those changes to a new write-ahead log or WAL file once per second to your remote storage. Looking in our AWS S3 bucket, we can see our web lightstream.SQLite path, which has a generations path as well. You will see a matching output from the Lightstream CLI as it creates a new generation. Opening this up, we will have a snapshots path and a WAL path. By default, snapshots are created daily on startup of Lightstream, but let's have a look at our WAL files and see them being generated as we make additional requests. Here we have some existing WAL files, and using our web interface to make another request and then refreshing our S3 interface, we can see another WAL file was added quickly. To be clear, your application is still using the SQLite file on your local disk, but Lightstream is creating a replica on S3 which can be used to restore your database from a specific generation, which combines a snapshot with the related WAL updates. We can see this in action by stopping our replication and application and deleting our SQLite file from our local disk. Once deleted, let's restore it as if we would in a disaster recovery scenario. We can do this using the command lightstream restore -o for output, space the path you want to restore your database to locally, space the same S3 path you used for the replicate command. By default, Lightstream will find the latest generation of your database that has been backed up, but you can also specify different generations or snapshots as needed. The file then reappears locally and we can view the contents using Rider. Refreshing the content and we can see that the previous state of our database has been restored and our application can run again from the same state. So now we have shown Lightstream working locally, let's have a look at the other two files in the mix templates that show an example of how you might put together an automated disaster recovery setup using Lightstream with your SQLite application. To do this, we're going to use one of the ServiceStack JavaScript-based Jamstack templates, which comes with a booking example app that is already wired up to SQLite. We will then push this project to GitHub with a Jamstack-specific Lightstream template mixed in and set up an automated deployment to a Linux host to show how this can work in a Docker-based scenario. Just like the previous templates, these use Docker Compose and Lightstream as a sidecar to manage this backup and restore process. This time, instead of running it locally, we will deploy our application using GitHub Actions to a Linux host set up with SSH access and Docker Compose installed. This follows the same deployment process that is baked into the template. The only difference is that it deploys Lightstream as a sidecar that our main application then depends on. It uses built-in Docker Compose health checks to ensure that the database is restored from backup if a backup is present on the remote storage and is missing on the local host, so it is ready to go before starting your main application container. To test this out, we're going to set up an application using the Vue SSG project template and mix in the Jamstack-Lightstream-AWS mix template to get the automated recovery with Lightstream incorporated into our system. There are also 3 of these templates as well, so if you want to use Azure or your own SFTP server, you can use the Jamstack-Lightstream-Azure or Jamstack-Lightstream-SFTP respectively. Again, we'll use the ServiceStack's Getting Started page to create our new Vue SSG application. At the top of the Getting Started page, there are multiple options for the different types of templates, including Jamstacks. Clicking on Jamstacks will take us to jamstacks.net, which has a variety of different Jamstack templates to use. Providing a name and clicking on Vue SSG, we get a zip of our new solution. extracting the zip to your desired working directory, and opening the API solution with your favorite .NET IDE, we can see the server-side API of our Jamstack application. Jamstack's templates are split into the UI and API folders, separating the statically generated front end from the ServiceStack API backend. We have videos of each of these templates if you want more in-depth walkthrough, but for now we will focus on the Lightstream functionality when the application is deployed. Running the xmix jamstack-lightstream-aws in the root folder will mix in a Docker Compose file and GitHub Action workflow called release.yaml. These two files will replace ones that were a part of the original project template with the ones that now support Lightstream. Adding this project to GitHub and pushing to the repository for the first time will trigger these actions, but the release workflow we've just added will fail since it's missing required GitHub Actions secrets that the template relies on. These secrets relate to deployment to a Linux server running Docker Compose. Check out our docs and videos related to these deployment variables, but for a quick overview, we're setting the following GitHub secrets for the release workflow. cr_pat, which is a GitHub personal access token with read-write access to packages, deploy_API, which is the host name of the application once deployed, in this case a subdomain A record, deploy_username, which is the remote username to log in via SSH, deploy_key, which is our SSH private key purely for deployments. And finally, let's encrypt_email for automatically registering TLS certificate via Let's Encrypt. These 5 secrets are common to the Jamstack templates, but we need an additional 3 secrets for setting up Lightstream access to S3. These are AWS S3 bucket, which is the name of the target S3 bucket your database will replicate to, AWS Access Key ID for programmatic read-write access to the specified S3 bucket, as well as the related AWS secret access key. Lightstream uses these variables from the Docker Compose template, but there are other ways to authenticate Lightstream with AWS that might be better suited to your scenario. Check out lightstream.io guides and the Lightstream GitHub for more information on those options. Once all these secrets have been added to our GitHub repository and our Linux host is set up with Docker Compose installed and the project templated Nginx proxy with the Let's Encrypt companion, we can run our release workflow to deploy our application. Once this GitHub action workflow has been completed and our application deployed, we can open our AWS S3 bucket in the console to view the files and see the initial Lightstream generation and WAL updates flowing into S3. Creating some additional bookings, we will see new WAL journals being added to S3 as expected. If we create bookings programmatically to simulate high load, we can see these WAL journal files being added to S3 once per second. Lightstream can restore from a specific generation by combining the related snapshot and WAL journals to return your database back to the last known good state. So while there is a chance for a small amount of data loss between WAL journal updates into S3, Lightstream gives us point-in-time restores combined with extremely cost-effective storage solutions like AWS S3 and Azure Blob Storage. Now that we have a bunch of extra bookings from our short load test, let's test out the disaster recovery process. By remoting to the Linux host, we can bring down our application using the command docker compose down and delete the Docker volume being used for the database. Our Linux host now no longer has the Docker container running or the SQL Lite file being used by our application. Let's redeploy our application from GitHub and step through what is happening. The GitHub action release workflow is building a new image of our application, pushing it to the GitHub packages repository and using SSH access to copy over a Docker Compose file and call a Docker Compose up command remotely. Our Docker Compose YAML file is set up with Lightstream as a sidecar that runs before our main application. It does this by using the depends on condition of service healthy on our application service and a health check process that attempts to restore our database on the Lightstream service. Once the health check and the restore has succeeded, Lightstream then runs the replicate command to create a new snapshot and starts generating our WAL files. Refreshing our deployed application, we can see our additional booking rows are back and have been successfully restored from S3. It's worth noting here that the health check process used by Docker Compose here has a timeout that is set to 10 minutes in the template. This is plenty of time for small databases to restore, but restore processes are something you should be testing regularly as your application grows. There are a lot of ways to automate restores on deploy, and they will likely depend on your hosting and deployment strategies. The main requirement here is that both the Lightstream restore and Lightstream replicate commands need to be run before your application restarts. How these commands are orchestrated is up to you and your specific environment, but we hope these templates can be provided as a guide for one way this can be achieved. Lightstream is a great tool that solves an important problem for those using SQLite for more production-like workloads. It also has some interesting use cases around distributed databases and multi-tenant setups where Lightstream can provide a way to cheaply create a level of reliability not usually associated with SQLite. For rapid development, the combination of SQLite and Lightstream is a great match that offers flexible, automated disaster recovery using cost-effective storage options. This not only simplifies your hosting, but it can also have a dramatic impact on your monthly bill. Here we have a comparison of our Jamstack bookings application running with Lightstream and SQLite on a DigitalOcean $48 droplet versus the recommended setup from Azure with MS SQL and AWS with Postgres RDS. Not only is the Lightstream setup 10 times more cost effective, we can comfortably handle 300 concurrent users browsing and creating bookings. Lots of internal applications and less data-intensive SaaS products will be well under this amount of load. And if you ever feel the need to migrate by using ORM Lite, a configuration change or swapping out the SQLite provider for another can be done when or if that time comes at all. Lightstream adds the much-needed disaster recovery support that enables the usage of a single server setup without compromising your data. This kind of setup is counter to the common cloud wisdom of always needing to scale horizontally. However, there are a lot of use cases that just don't need to, and where a single server is more than capable of doing both while saving you money you never needed to spend in the first place. Let us know what you think in the comments. Is Lightstream something you can see yourself using? Something you would be interested in seeing more examples of? Or do you prefer to pay and stick with the managed offerings like AWS RDS or Azure SQL databases, even for your prototypes and small applications? Well, that's it for this video. If you have any suggestions or feedback about our templates or videos, you can let us know in the comments as well. If you want to learn more, check out our other videos and join us in the ServiceStack community through our Discord and GitHub discussions. ServiceStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.